Hey guys, welcome back to our Aptos development course. Today we're going to learn smart contract development on Aptos. Since you've been following this along, you know that Aptos is shaking things up in the blockchain space, and its approach to smart contracts is no exception. Let's start with a quick comparison with this diagram. As you can see, Aptos brings some unique features to the table. We are dealing with Move, not Solidity or Rust. And remember how we talked about Move's resource-oriented programming model? That's going to play a big role in how we structure our contracts. So here's a quick example of what a basic Move contract might look like. Notice how we're using a token store resource to manage balances. This resource-oriented approach is fundamental to Move and Aptos. Another key difference is Aptos' parallel execution engine. This isn't just a performance booster, it fundamentally changes how we need to think about our contract logic. We need to design with concurrency in mind from the get-go. Lastly, Aptos has a different approach to smart contract upgradability. It's more straightforward in some ways, but it comes with its own set of considerations that we'll learn later. Now let's walk through the lifecycle of a smart contract in Aptos. If you've developed on other blockchains, this might feel familiar, but there are some Aptos specific things you'll want to keep in mind. Let's start with development. So you're writing Move code, leveraging those resource-oriented features we've talked about, but here's where it gets interesting. You're not just thinking about your contract in isolation. You need to consider how it might be executed in parallel with other transactions. For example, let's say we are updating our basic smart contract token to include a transfer function. This function looks straightforward, but we need to consider what happens if multiple transfers involving the same accounts occur simultaneously. Aptos' parallel execution model will handle this for us, but it's crucial to understand it first. Next up is testing. Aptos provides a robust testing framework that allows you to write unit tests in Move itself, like this. So when it comes to deployment, Aptos uses a two-step publishing process. First, you compile your Move bytecode, then you publish it to the blockchain. This is different from Ethereum's single-step deploy, and it gives you a chance to verify your bytecode before it goes live. Upgrading contracts in Aptos is more straightforward than in some other blockchains, thanks to native upgradability. However, there's a catch. While you can upgrade your module code, you can't arbitrarily change existing resources. This means you need to plan your data structures carefully from the start. Throughout this lifecycle, the parallel execution model remains a key consideration. At every stage, from development to upgrading, you need to think about how your contract will behave when multiple transactions hit it simultaneously. It's a different way of thinking, but it's key to leveraging Aptos' full potential. All right, let's talk about how to structure your Aptos smart contracts and some best practices to keep in mind. So you can see in this diagram, also in the code, so we're trying to use everything in the proper manner, but if you're not familiar with constant structs and other concepts in Move, then I recommend you check out our episodes 1 to 5. There we've covered most of these things in detail. And now let's talk about the best practices. So we can break our contract into logical modules. This improves readability and makes upgrading easier. And we can leverage Move's resource types for anything that represents ownership or unique assets. And you need to comment your code thoroughly. You can use the 3 slashes for function documentation that can be picked up by the tools. And use snake case for functions and variables and Pascal case for structs and resources. Remember, in Aptos, your contract isn't just a standalone entity, it's a part of a parallel execution environment. Always think about how your functions might interact when called simultaneously. Now we're going to learn about a really important topic in Aptos and the Move language, which will help us create good quality contracts in the future. The asset standard and the object model. These features are what set Aptos apart and make it a powerful platform for building next generation decentralized applications. So first, let's talk about the object model. This is the foundation of Aptos' new asset standards. Imagine being able to group related resources together, give them their own address, and treat them as a single entity on the blockchain. That's exactly what the object model allows us to do. Now onto the asset standards. Aptos introduces 2 main standards, digital assets and fungible assets. The DA standard is perfect for NFTs or semi-fungible tokens. It's flexible, extensible, and built on top of the object model. The FA standard, on the other hand, is designed for fungible assets. It's meant to replace the old Aptos coin standard and offers more features and better type safety. Let's look at how we can create NFTs using the digital asset standard, which is the recommended and standardized approach. This code demonstrates how simple it is to create NFTs using the DA standard. The standard provides built-in features like direct NFT transfers without recipient opt-in, token extensions through Move objects, NFT composability, built-in royalty support, automatic collection management. Now when working with these standards and the object model, there are some best practices to keep in mind. Always use named objects for important assets to ensure deterministic addresses. Implement proper access control using the object model's capabilities. And don't forget to use even handles for important state changes. For those of you transitioning from the legacy Aptos token or Aptos coin standards, while these are still supported, I highly recommend using the new DA and FA standards for new projects. They offer more flexibility, better type safety, and leverage the full power of the object model. Remember, the beauty of these new standards is not just in their current capabilities, but how they set the stage for future innovations. As you build on Aptos, think about how you can use these tools to create assets and applications that weren't possible before. Alright, now that you know all this, let's talk about one of the most exciting aspects of smart contract development, making our contracts talk with other contracts. On the Aptos blockchain, this is where things get really interesting. Now, if you're coming from Ethereum or Solana, you might be used to thinking about smart contract interactions in terms of external calls or cross-program invocations. But in Aptos, we've got a slightly different approach. We call it cross-module calls, and it's all about leveraging the power of Move's module system. So just look at this code. We're interacting with two different token modules here. We're drawing one token, minting another, and even burning tokens. All of this is happening across different modules, but it feels seamless, doesn't it? If you're feeling really confused after seeing this, I will be covering this in detail when we build the project and use all features. Now here's where it gets really cool. In Aptos, when you're calling functions in other modules, you're not making an external call in the traditional sense. It's all part of the same transaction executed atomically. This means you don't have to worry about parallel execution or complex rollback mechanisms. But with great power comes great responsibility. When you're designing for interoperability, you need to think carefully about your module's public interface. What functions should be callable from other modules, what resources should be accessible, and here are some best practices to keep in mind. Use the public keyword carefully. Not everything needs to be accessible from other modules. Consider using friend modules for controlled access to internal functions. Always validate inputs even when they're coming from another module you trust. Think about how your module might be used or misused by others. And here's a pro tip: document your public interfaces thoroughly. Your future self and other developers will thank you. All right, let's tackle one of the most crucial aspects of smart contract development, which is upgradability. Now, I know that some of you might be thinking upgradable smart contracts, isn't that an oxymoron? Well, in Aptos, it's not only possible, it's built right into the system. Let's start with a visual to understand how upgradability works in Aptos. Let's break it down. In Aptos, upgrading a module is essentially publishing a new version of your module to the same address. Sounds simple, right? Well, there's a bit more to it. First off, Aptos performs a compatibility check. It ensures that your new module version doesn't break existing data structures or remove public functions that other modules might be relying on. This is crucial for maintaining the integrity of the blockchain state. Let's look at an example of how you might structure an upgradable contract. The structure allows for future upgrades while maintaining backward compatibility. The module data resource keeps track of the current version, which can be used for managing state migrations across upgrades. Now here's where it gets tricky. While you can add new fields to existing structs, you can't remove or change the types of existing fields. This is part of Aptos' compatibility guarantee. So how do you handle major changes? There are a few strategies. Additive changes, so always prefer adding new fields or functions rather than modifying existing ones. Versioning, use version checks in your functions to handle different logic for different versions. Proxy pattern, for more complex upgrades, you can implement a proxy pattern where a proxy module forwards call to the latest version of your logic module. Remember, just because you can upgrade your contract doesn't always mean you should. Each upgrade increases complexity and can potentially introduce new bugs. Always thoroughly test your upgrades, preferably on a testnet first. Also, an important feature in Aptos is the ability to permanently freeze your contract from future upgrades. You can do this right in your move.toml file by setting the upgrade policy to immutable. It looks something like this. This is particularly powerful when you want to build trust with your users by guaranteeing that your smart contract's functionality will remain unchanged forever. Think of it as setting your code in stone. Once deployed, no one, not even you, can modify it. Always communicate your upgrade plans and processes clearly to your users. Transparency goes a long way in building trust in your dApps. Upgradability in Aptos offers a powerful way to evolve your smart contracts over time, but requires careful planning and a deep understanding of the implications. Always think about backward compatibility, state migrations, and how your upgrades might affect other modules that depend on yours. That's a wrap for this session on Aptos smart contract development. We covered a lot of ground, from understanding the lifecycle of contracts, best practices, and new asset standards to exploring interoperability and upgradability. By now, you should have a solid understanding to start building your own smart contracts on Aptos using the Move language. As you continue your journey, remember to keep experimenting with different patterns and exploring more advanced concepts. The Aptos ecosystem is evolving rapidly, and there's so much more to discover. In the next video, we'll dive into creating a real-world project, combining everything we've learned so far. Thanks for watching, and don't forget to like, subscribe, and hit the bell icon to stay updated on our upcoming content. See you in the next one.